Hello everyone, my name is Masudur Rahman Saim. I'm a solutions architect at AWS. Running large-scale database workload is operationally challenging. I'm here today to talk about how customers are using Amazon DynamoDB for their mission-critical application, and I will also share a few tips to effectively use Amazon DynamoDB. But before I talk about Amazon DynamoDB, I want to take a minute to talk about how internet scale application changed the access pattern of using a database. The growth of internet scale web applications such as e-commerce, social media, the explosion of connected devices such as smartphones and tablet, and the rise of big data have resulted in new workloads that traditional relational databases are not well suited to handle. Scaling an RDBMS to handle concurrency while maintaining strong consistency requires upgrading to more powerful and often proprietary hardware. This is called scaling up or vertical scaling. And it usually carries an extremely high cost. NoSQL databases address the scaling and performance challenges found with RDBMS. NoSQL databases trade some of the query capabilities and ACID properties of an RDBMS for much more flexible data model that scales horizontally. These characteristics make NoSQL databases an excellent choice in situations where use of an RDBMS for non-relational workload is resulting in some combination of performance bottleneck, operational complexity, and raising cost. Amazon DynamoDB offers solutions to all these problems and is an excellent platform for migrating this workload of an RDBMS. Before I jump into customer stories, let me give you a short summary of what Amazon DynamoDB offers. Amazon DynamoDB is a fully managed NoSQL database service running in the AWS cloud. The complexity of running a massive scale distributed NoSQL database is managed by the service itself, allowing software developer to focus on building applications rather than managing infrastructure. NoSQL databases are designed for scale, but their architecture are sophisticated, and there can be significant operational overhead in running a large NoSQL cluster. Instead of having to become an expert in advanced distributed computing concept, the developer need only to learn DynamoDB's straightforward API using the SDK for the programming language of choice. In addition to being easy to use, DynamoDB is also cost-effective. With DynamoDB, you pay only for the storage you are consuming and the I/O throughput you have provisioned at what you are consuming. It is designed to scale elastically while maintaining high performance. When the storage and throughput requirement of an application are low, only a small amount of capacity needs to be provisioned in DynamoDB service. As the number of users of an application grows and the required I/O throughput increases, additional capacity can be provisioned on the fly. This enables an application to seamlessly grow to support millions of users, making thousands of concurrent requests to the database every second. And finally, DynamoDB is secure with support for end-to-end encryption and fine-grained access control. There is no practical limit on DynamoDB, so your table can be in any size. With DynamoDB, there is no instance, no server to manage. You create a table and you start using it, where the service distributes that workload on hundreds, even thousands of nodes, and it is managed for you automatically. We offer availability SLA on the service. You don't have to do all those work related to managing the infrastructure for such highly complex system. That frees you to go focus more on your own application and releasing new features. For that, we have lots of customers using Amazon DynamoDB building mission-critical application. DynamoDB has changed a lot since the initial launch, and as you can see, we have a very diverse customer base that includes companies from financial, manufacturing, retail, automotive, internet services, brand new startups, old startups, and enterprises that have been around for a very long time. And I hope that we can continue to innovate on your behalf and meet your expectation for an awesome database. Let's now deep dive on some of the customer stories using Amazon DynamoDB. Here is an example from Nike Digital. They use broad sets of microservices for serving digital experience like Nike.com, time zone, and launching shoes when they see huge influx of traffic. And Nike activity platform that allows a runner or trainer to earn an achievement. Nike started their very first digital journey with Nike.com as a traditional monolith application with off-the-shelf Oracle product in a data center co-location facility. It was hard to scale. You generally only can scale such infrastructure vertically instead of horizontally. And they also found challenges to meet their scale need. Nike started their cloud journey breaking the monolith, and they started adopting cloud-native solution with microservice-based architecture. Those microservices needed a database to meet their growing demand, and moving to a horizontally scalable database was absolutely makes sense. So they first tried with Apache Cassandra. Nike has lots of global brand. They generate lots of data, and the database side, they need lots of throughput. So having a horizontally scalable database is really a good fit for their use cases. And some of their use cases required caching. For such, they initially choose Couchbase. Things like for Nike product data. As Nike started building out, they had more and more team. They identified the new team don't have much production experience to fine-tune the database for the performance they need. It becomes a bottleneck where they were relying on few SMEs to handle that situation, and database maintenance become extremely challenging, like provisioning, patching, upgrade, backup, and restore, which was taking time away from the engineering team. Instead of building feature, trying something cool, the team was busy managing the infrastructure. Lots of their cluster were also over-provisioned and underutilized. In many cases, they had to over-provision for data durability and availability. They found they are wasting tons of money. Also, they have various different workloads where some of them are read heavy, some of them are write heavy, and some teams have specific requirement, which was really challenging to match. They identified it's really hard to manage all those on Cassandra and Couchbase. For example, when there is an easy to determine notification or upgrading to a newer version is always challenging. Replacing node from a Cassandra cluster is complex. You have to follow a runbook and hope something will not go wrong. To overcome those challenges, they migrated to DynamoDB. Instead of over-provisioning from the peak load, they now use scheduler scaling to scale up and down the capacity based on their demand. And they can do it seamlessly without having any downtime. They also use DAX, which is a fully managed in-memory cache for DynamoDB. With DynamoDB Global Secondary Index feature, they can handle different query patterns efficiently. For example, in Couchbase, you have to do double write for such capability, or in Cassandra, you can have materialized view, which involve lots of code and process. Global Secondary Index feature allowed them to evolve their data model very rapidly, and conditional update helped them for the fine-grained locking. DynamoDB solved Nike's scalability issue. The service seamlessly scales on demand basis, which makes their data store more cost-effective instead of over-provisioning and doing all those undifferentiated heavy lifting for database maintenance. They achieve durability out of the box, where the service store multiple copies of the data automatically. With integration with CloudWatch, it's much easier to monitor the database performance, and team knows exactly what's going on their production application, as well as setting alarms when things are not going right. Nike dropped their overall database cost by 98% after migrating to DynamoDB, and DynamoDB has become the new default. Here is another story from GumGum. The digital advertising facet of gumgum employs proprietary AI and computer vision techniques. They have a requirement to store massive scale metadata of images, pages, users that can handle extremely high traffic with very low latency. GumGum deployed Apache Cassandra with more than 100 nodes running on i3 2x large EC2 instances across multiple geographic locations. The scale of their database was growing every year, and their Cassandra cluster started becoming unstable with occasional outage. In digital advertising, outages are an expensive affair which cost considerable revenue loss as well as are exhausting for engineers. They realized they need a new data store which would require less engineering, especially for maintaining, and at the same time very easy to scale while providing the same performance. After doing much analysis on Apache Cassandra Enterprise, Redis Enterprise, AWS Enterprise, and Amazon DynamoDB, they have chosen DynamoDB, which is a fully serverless solution, abstract the complexity of node level management, and makes it easy for developer to maintain and scale the system without compromising the performance. With the managed TTL feature, DynamoDB helps them keep the data from growing too large. Time to leave or TTL for DynamoDB allows them to define when items in a table expires so that can be automatically deleted from the database at no extra cost and without consuming throughput from the table. When they started the project, the DynamoDB global table feature was not available. So they also use DynamoDB Stream to replicate their data across multiple regions. As a result, GumGum observed all of their read-write happening in less than 4 to 5 millisecond latency. It's almost 2 years customer has not faced any outage, which is a big win for them. They also have very minimal throttling on their table. GumGum can now scale up and down their database at needed basis. GumGum achieved 65 to 70% cost saving after migrating to DynamoDB. Here are some operational states where they are storing more than 2 terabytes of data with more than 16 billion items, and it's growing. They are doing 8 million read per minute with less than 3 millisecond read latency consistently on DynamoDB. GE Aviation is a world-leading provider of aviation jet and turboprop engines and components. Every 2 seconds, an aircraft with GE engine technology takes off. As the engine in the air or when it takes off, it generates lots of data, which is over 40 terabytes of data on demand, approximately 175 billion rows, essentially a time series data. To handle the data volume, they initially migrated to Cassandra. They quickly seen the performance degradation, especially for hot spotting. To help with that, they had to scale up, which makes their Cassandra cluster very costly. They have also seen high overhead on their cluster, as when they add more nodes to the cluster because of data movement and repartitioning. Cassandra don't do that automatically. You need to be a skilled DBA to do that, and maintaining backup with Telena was hard. They also saw increased query latency. Query was working fast for the latest data. However, for historical data, it was very slow. One of the key issues they found was they always had to architect for the max volume. After dealing those issues for a while, the team decided to move to Amazon DynamoDB. They instantly saw performance improvement. The most appealing thing for them was DynamoDB scales automatically based on their demand. No more compute or storage over provisioning. They also realized it requires nearly zero maintenance, no OS patching, software upgrade, or server provisioning. From 40 instance Cassandra cluster, GE Aviation migrated to 5 DynamoDB tables. With no additional server for taking backup, helps them having much smaller footprint on their database. Now with a click of a button, they can take backup of their data, and there is no impact of taking backup while running large-scale production traffic. They can now scale database based on their demand without over-provisioning, and with elastic storage feature of DynamoDB, they don't need to do any storage planning. GE can now ensure 11 to 16 millisecond query latency of more than 40 terabytes of on-demand data. With all these, they have been able to reduce 72% of their database cost. We are seeing a big swing in customers looking to move self-managed large relational and NoSQL workload to DynamoDB. We routinely hear from CTOs who says that things started well on proprietary relational database or open source NoSQL database, but managing at scale is costly and complex. It's particularly difficult to find the expertise to support a distributed database. Samsung used to have engineering team maintaining Cassandra cluster. After migrating to DynamoDB, those teams can now focus on building features instead of operational tasks to keep alive a mission-critical database. As a result, Samsung launches their Samsung Cloud Service using DynamoDB as their primary data store. It serves more than 300 million users requests, 130 million daily API call, more than 1 petabytes of data with zero capacity planning and zero administration. They have not seen any failure or any data corruption of their 2+ years of operation running massive scale workload on DynamoDB. Switching to DynamoDB also helped them reduce 40% of their cost. Here is another story from Amazon.com. When customers across the globe place orders on Amazon.com, those orders are processed through many different backend systems. One of those key systems is HARD, a workflow orchestration engine developed by Amazon e-commerce foundation team. If such a mission-critical system don't work, the customer impact could be significant. HARD team were struggling to keep the system running smoothly on more than 150 Oracle databases. It was hard to scale. Scaling to events like Amazon Prime Day, Cyber Monday required extensive manual effort. As the system scaled, team members spent an increasing percentage of their time managing system operation. It was causing huge delay on data processing. To solve this availability and scalability concern, the HARD team moved the system from Oracle to Amazon DynamoDB. They take the advantage of DynamoDB Global Secondary Index for efficient access of their data with many different access patterns. With auto-scaling feature of DynamoDB, they now don't need to over-provision, and they don't need any downtime for software upgrade or for partitioning their data. The HARD team moved all of their database to DynamoDB. During the 2016 holiday season, all HARD workflow ran on DynamoDB for the first time. The result was impressive. The HARD team reduced workflow processing delay by 90%. They also reduced their time needed to scale for large events from 60 weeks to 6 weeks. If they were still running on old architecture, they would have had to use more than 1,000 hosts running Oracle software to support Amazon Prime Day. With DynamoDB, they handle more than 4 billion workflow daily at peak with 10x performance improvement. So far I talked about how customers are using Amazon DynamoDB for large-scale workload. Let's now shift the gear. I want to give you some best practice guideline to get best out of DynamoDB. AWS portfolio of purpose-built database supports diverse data model and allows you to build use case-driven, highly scalable distributed application. By picking the best database to solve a specific problem or a group of problems, you can break away from restrictive one-size-fits-all monolith databases and focus on building applications to meet the need of your business. So first, understand the use case. What is the nature of your data? Whether this is an analytics workload, it may be best suited with data warehouse solution like Amazon Redshift, or this is a transaction processing workload. In that case, DynamoDB could be your primary data store. Do you have a requirement for full text search? In that case, DynamoDB Stream can help you to build full text search capability by replicating data to Amazon Elasticsearch. Do you need cryptographically verifiable and immutable data store? Amazon QLDB is a purpose-built database for this type of workload. And then, understanding relationship between entities is also very important. Though it is not recommended to follow the RDBMS normalization design technique and using multiple tables, if your workload is new, starting with entity relationship modeling will help you to understand the relationship between entities clearly, and you can apply the best schema design on DynamoDB. Also check if the data is in time series in nature. Your read access pattern might be to read today's event more frequently, yesterday's event much less frequently, and then older events very little at all. For this, create one table per period. Before the end of each period, pre-build the table for the next period. Reduce the capacity on the old table to a lower value. Popular items are those where application reads a small number of items more frequently than others. For example, consider an e-commerce system that has a one-day sale on a popular product. During the sale, demand for that product and its data in DynamoDB would sharply increase compared to all of the other products. To mitigate the impact of a hotkey issue and a non-uniform data distribution, you could offload the read activity to a fully managed in-memory cache DynamoDB DAX until the one-day event is over. One of the key requirements to get best out of DynamoDB is distribute your request across key space as uniformly as possible. However, in many cases it is hard to do. Here is an example where in a voting application you have two candidates getting hundreds of thousands of votes per second, and you have chosen candidate ID as the partition key. As you can see, you have a very low cardinality on the key space, which will create hotkey issue. One way you can handle this is adding a random number with a known range on partition key. This way, you can distribute the traffic across multiple keys. Choose the capacity model best suited for your application. Amazon DynamoDB has two read-write capacity modes for processing reads and writes on your table: provision mode and on-demand mode. Provision mode will be cost-effective if you have a steady and predictable load. Use auto-scaling if you are using provision mode to automatically scale up and down capacity based on consumption. If you are unsure about the table load or if the traffic on your table is spiky, on-demand mode will help you providing capacity need basis seamlessly. You only pay what you consume instead of over-provisioning capacity on your table. My recommendation would be, if you are unsure about table load, start with on-demand and monitor table consumption for a period of time and decide whether you can switch to provision mode or on-demand mode is best suited for you. Capacity planning is very important. Understand how much capacity you need, especially if you have an upcoming event. One read capacity unit represents one strongly consistent read per second or two eventually consistent read per second for an item up to 4 KB in size. One write capacity unit represents one write per second for an item up to 1 KB in size. In DynamoDB, a single partition can handle 3000 read and 1000 write per second. So the question can come to your mind, how DynamoDB handle millions of requests per second on a table? Well, the answer is the service allocate that many partitions on your table so it can handle millions of requests per second. As a simple math, if the table need to handle 2000 write per second, it requires 2 partitions. Let's say for your upcoming event, you know you need to handle 80,000 write per second at peak. To handle the peak load, switch to provision mode and allocate 80,000 WCU prior to the event and switch back to your original table configuration. The advantage of doing this exercise is your table now ready to handle your peak traffic without repartitioning your data. Allocating 80,000 WCU will be very quick next time, and if you use on-demand mode, it will be instant. And know your account limit. Each AWS account has a soft limit on maximum read capacity unit and write capacity unit you can provision on a DynamoDB table. This limit can be increased by contacting AWS support. However, knowing and monitoring those limits is important, so you can take proactive action before impacting your production. You can use Describe Limit API to know your current limit. And recently, DynamoDB released a feature where it published account metrics to help you monitor capacity consumption against your account limit. You can now alarm as your capacity approaches your account limit and proactively request limit increases. This will ensure your DynamoDB table are always available. And check whether you need to store large item. DynamoDB currently limits 400 KB size of each item. If your item size is big, think carefully whether you actually need to store it together on the same item or you can split it in multiple items. Here is an example where I have user ID, ranking, and some other information in metadata column. And I'm storing 2 KB data on metadata attribute. Let's say I'm frequently updating ranking for the user, but there is no frequent change on metadata attribute. However, in this scenario, DynamoDB will consume the write capacity unit considering the total item size. Means it will consume 3 WCU to update the ranking information, as your item size is more than 2 KB. And one write capacity unit can handle 1 KB write per second. But if you split the metadata information as a separate item, just to update the ranking information, DynamoDB will consume 1 WCU. If you still need to store large item, check whether you can compress those items, or if your item size is larger than 400 KB, store them as an object in Amazon S3 and then store the object identifier in DynamoDB item. Monitor table activity using Amazon CloudWatch. Check your read and write consumption. If it is steady and you think you need that capacity for a long time, consider reserving the capacity to reduce cost. Monitor read and write throttling. If this is happening over a long period of time, identify the root cause. In most of the cases, for provision mode table, if your consumption is less than what you provision but still you see throttling, there is a high chance it is happening due to hotkey issue. Log the throttling information which will help you to identify the hotkey. Monitor read and write latency. DynamoDB provides single-digit millisecond latency on average, where your item size for write is less than or equal to 1 KB, and for a strongly consistent read, where your item size is less than or equal to 4 KB. And monitor the system error. Most of the cases, system error for such large distributed system is transient and resolves automatically. However, if you observe system error on your table for a long period of time, and if it is impacting your production, please engage with AWS support immediately. Understand the behavior of Global Secondary Index or GSI. DynamoDB GSI allows efficient access of your data with attributes other than the primary key. When you write to your table, the service asynchronously replicates the data to your GSI. For updating GSI, DynamoDB consumes GSI write capacity. Let's say you are consuming 100 write capacity unit per second to write to your table, but you only provision 1 write capacity unit to your GSI. In that case, your base table will eventually start throttling for not being able to synchronize data to your GSI with the same speed. If you're unsure how much capacity you need on your GSI, start with matching the base table write capacity unit. You can have different read capacity in base table and GSI, and check whether you need to store all base table attribute to your GSI. If you know exactly what you want to read from GSI, exclusively specify those attribute name instead of synchronizing all base table attribute. This will help you to reduce the storage and throughput usage on your GSI. There may be a situation where you want to sort your record with alternate sort key. To give your application a choice of sort key, you can create one or more local secondary index or LSI on a table. For LSI, there is a 10 GB size limit per partition key value, and this is a hard limit. So when you're choosing LSI, check whether you will hit that limit and avoid creating LSI in that situation. LSI use the base table capacity for read and write. For example, if an update to the table changes the value of an index key attribute, 2 writes are required. For index queries that read attribute that are not projected into the local secondary index, DynamoDB will need to fetch those attributes from the base table, incurs a high throughput cost. So understand your LSI access pattern and provision capacity accordingly to your base table to handle base table operation and index operation. Also, LSI can only be created when you create the table, and you cannot delete the LSI. On the other hand, GSI is flexible to delete and create anytime you want. The major difference between LSI and GSI is LSI support strongly consistent read and GSI support eventually consistent read. If you don't have a strongly consistent read requirement, I would recommend to use GSI instead of using LSI. Think about attribute length as well. DynamoDB tables are schemaless. The total size of an item is the sum of the length of its attribute names and value. In relational database, usually having meaningful name of attribute is common practice. But NoSQL database like DynamoDB, where your table is schemaless and where you store data in a denormalized form, combining multiple entities on a single table is a best practice. Use generic attribute name for your primary key attributes like PK for partition key, SK for sort key. Also make other attribute names shorter. Here is an example where you have 1 billion items and each item size is 66 bytes. It will consume 66 GB storage to store those items on DynamoDB. But if we just shorten the attribute name like FN instead of full name, BD instead of birth date, and HA instead of home address, you can reduce the item size to 44 bytes. Now to store 1 billion item, you need 44 GB storage, meaning you can save 22 GB storage consumption just reducing the attribute length. Here is another example how reducing the attribute size can reduce throughput consumption. As I mentioned earlier, one write capacity unit represents one write per second for an item up to 1 KB in size. In this example, we are writing 10,000 items per second where each item size is more than 1 KB, which means to write each item we need 2 WCU or write capacity unit, and total we need 20,000 WCU on this table. Just shortening the attribute name highlighted here, you can make each item size smaller, less than 1 KB, and you can now reduce the throughput consumption to half from 20,000 to 10,000, a huge cost saving. Use DynamoDB Stream feature. DynamoDB Stream captures information about every modification to data items in the table. This is one of the powerful features of DynamoDB where, without impacting the performance on your table, you can react on data changes in near real time. For example, you can build an application automatically sends notification to the mobile devices of all friends in a group as soon as one friend uploads a new picture. DynamoDB Stream is integrated with AWS Lambda, which will make it easy to build trigger-based application with a piece of code that automatically respond to events in DynamoDB Stream. Also use the power of Manage TTL feature. Customers often use DynamoDB to store time series data, such as web page clickstream data or IoT data from sensors and connected devices. TTL is useful if you have continuously accumulating data that loses relevance after a specific time period and you want to delete those items. Instead of using custom code to delete older item, DynamoDB TTL simplifies this process by automatically deleting item based on the timestamp attribute of your choice. So in your application design phase, check whether you have data which needs to be deleted in future date. In that case, specify a TTL value when you are writing the item and let DynamoDB TTL handle the delete operation automatically. And there is no extra cost and performance impact with TTL operation. You can also use TTL with combination of DynamoDB Stream to automatically archive deleted item to S3. And get started building with Amazon DynamoDB on the AWS Management Console, especially on schema design phase to test whether you can run query on base table or whether adding an index will help you to run additional query, or even checking if additional filter expression can help you to get the data that you want. All those testing is faster using DynamoDB console comparing to start writing code and spending hours just to debug your application code. And take the advantage of managed feature from the service instead of building and managing by your own. DynamoDB was built on the principle of original Dynamo paper that Amazon published in 2007. Over the years, lots of new features have been introduced to further simplify how AWS customers use databases. You can now create fully managed multi-region, multi-master database table with features such as encryption at rest, point-in-time recovery, in-memory caching, 20 global secondary index, and a 99.99% standard uptime service SLA. Encryption at rest is on by default. So get the advantage of all those managed features and capabilities. So what to do next? We are continuously adding features, also publishing blogs on AWS Database blog. Follow us on Twitter to know the latest on DynamoDB. Check DynamoDB resources, best practice guideline, also digital course. Recently, we launched a self-paced digital course of DynamoDB on edX. As I mentioned earlier, DynamoDB is a key value and document database. DynamoDB handles more than 10 trillion requests per day with peak more than 20 million requests per second over petabytes of storage. So build your application using Amazon DynamoDB and let DynamoDB handle the heavy lifting for you. That's all for now. Thank you all for taking your time. We hope this session is useful and we look forward to seeing you in future Tech Talk session.